26. Manholes are constructed along the sewer line to receive the sewage from the various sewers and from the various direction. And it is also provided to achieve the ventilation of sewers. Now location of manholes. Basically manholes are constructed at a distance of varies from 75 to 300 meter if the length of the alignment is the straight, and it is also provided when the situation of meeting main sewer and branch sewers, and also provided at the change of the gradients and the size of the sewers. One more important location of this manhole is it should be provided at all changes of the directions. Now coming to the question, manholes are built at a regular intervals of. Here the interval range for the manholes, the minimum interval is starting from the 75 meter, so that option 2 and option 4 are directly eliminated. Now considering average interval, so that the most appropriate answer will become 100 to 200 meter. So option 3 is the correct answer. Question number 77. This question I already explained in first video. Please go through that video. Answer for this question is 1440 kilonewton. So option 4 is the correct answer. Question number 78. A constant head permeability test was carried out on a cylindrical sample of sand whose diameter is 10 cm and height is 15 cm. Means they given the diameter of the sample, that is 10 cm, convert this into meter, that is 0.1 meter, and the length of the sample is 15 cm, convert this also into meter, that is 0.15 meter. 160 meter cube of water was collected in 1.7 minutes under a head of 30 cm. Means they given the volume of water, that is 160 meter cube, and this volume of water will collected in 1.7 minutes, that is t equal to 1.7 minutes, and it is under a head of 30 cm. Convert this h also in meter, that is h equal to 0.3 meter. Remember, constant head permeability test is suitable for the coarse grain soil, so sand is also the example for the coarse grain soil. Now coefficient of permeability for sand under the constant head permeability test was given by K equal to QL upon AHT. Put the value of Q, that is 160, and length of the specimen is 0.15 meter. Use area formula pi by 4 into d square. So diameter is 0.1, so 0.1 square. Head in the test was 0.3 and water collection time is 1.7 minutes. Simplify this, then you will get coefficient of permeability for sand 5991.7 meter per minute. Convert this into meter per year, that will become 3.15 into 10 raised to 9 meter per year. No options are matching to the answer, so you may get grace marks for this question also. Now moving to next question. A project expected to take a 15 months along the critical path, means they given the expected time of the project 15 months and having the standard deviations of 3 months. They given the standard deviation of 3 months, and what will be the permeability factor for completion of the project within the 8 months. Means they given the project completion time, that is 18 months. We have permeability factor Z equal to completion time minus expected time upon the standard deviation. Completion time of project is 18 months minus expected time is 15 months and the standard deviation is 3 months. Simplify this, then you will get permeability factor Z equal to 1 month. So option 1 is the correct answer. Question number 80. The time when an event can expected to occur is called as the earliest expected time. So this is simple and direct question from the project management. So option 2 is the correct answer. Question number 81 is asked from railway engineering. First of all, we have to know what is gauge. Gauge, it is the clear horizontal distance between the inner faces of two rails. Then the gauges are divided into 4 types: broad gauge, meter gauge, narrow gauge and light gauge. Broad gauge distance is 1.676 meter and meter gauge is 1 meter and narrow gauge is 0.762 meter and for the light gauge is 0.610 meter. Other than the standard gauge used in Delhi Metro is 1.435 meter. Now coming to the question, the minimum distance between two rails for broad gauge railway track in India is 1.676 meter or 1676 mm. Option 2 is the correct answer. Question number 82. An embankment of height 2 meter and the top width of embankment is 2 meter with the side slope of 1:1. Draw the embankment with respect to given data of height 2 meter and top width 2 meter. And they given the side slope of 1 vertical is to 1 horizontal. They given the vertical dimension 2, then horizontal dimension is also become 2 meter. and it having the unit weight of 18 kilonewton per meter cube at water content 10%. They given the unit weight of soil, that is gamma equal to 18 kilonewton per meter cube and water content W1 equal to 10%. If the water content is to be increased to 14% without change in the voids ratio, so take W2 equal to 14%. And now what quantity of water required to be added for 2 meter length of embankment? So they clearly mention that the length of the embankment is 2 meter. First of all, we need to find out the volume of the embankment. We know that volume equal to cross sectional area into length. The embankment is in the shape of trapezoidal, so divide into rectangular and triangles. Divide this trapezoidal into one rectangular and two triangles. Now area of the rectangular portion, that is width into depth. Width is 2 meter and depth is also 2 meter. Now finding the area for the triangular portion, that is half into base into height. Base is 2 meter and height is also 2 meter. And the number of triangles are 2. And the length of the embankment is 2 meter. Simplify this, then you will get volume of embankment equal to 16 meter cube. Now apply the unit weight formula, that is gamma B1 equal to G into 1 plus W into gamma W upon 1 plus E. Put the value of gamma 1, that is 18. Put the value of first water content, that is 10%. Convert this into fraction, that is 10 by 100 equal to 0.1 divided by 1 plus E into gamma W. Make this as equation 1. Now apply same unit weight formula for the second water content, that is 14%. Convert this also into fraction, that is 0.14 and make this as equation 2. Now dividing equation 2 by equation 1, that is gamma B2 upon gamma B1. 1 plus C get cancelled and gamma W is also cancelled and G also. On the numerator we only have 1 plus 0.14. Add this, that will become 1.14 and denominator also same, add 1 plus 0.1, that is 1.1. Take 18 into right hand side and simplify this, then you will get gamma B2 equal to 18.65 kilonewton per meter cube. Density of soil sample equal to mass upon volume. We need to find the mass of soil, so that's why take volume into left hand side, then mass will become density into volume. Now find the mass of value for first water content, that is density into volume. Put the gamma B1 value 18 and volume of the embankment is 16. Multiply these two, then you will get mass of soil for first water content is 288 kilonewton. And similarly find the mass of soil for second water content. Same second density of soil, that is gamma B2 equal to 18.65 and the volume of embankment is 16. Same here also multiply these two, then you will get mass of soil for second water content is 298.4 kilonewton. Now we find how much water is to be added for the embankment. That is mass of second soil minus mass of first soil. That is equal to 10.4 kilonewton. Convert this in terms of meter cube. For that divide 9.81. Then you will get weight of water equal to 1.06 meter cube. 1.068 meter cube is the correct answer. So hence option 1 is the correct answer. Question number 83. These all are the index property of soil. It is also called as the Atterberg's limits. Plasticity index IP equal to WL minus WP. Here WL means the liquid limit and WP means plastic limit. And liquidity index is given by WN minus WP upon IP. Here WN means natural water content. And consistency index IC is given by WL minus WN upon IP. Similarly, toughness index is given by IP upon IF. Here IF is the flow index and it is given by tan theta equal to W1 minus W2 upon log N2 minus log N1. Now coming to the question, consistency index of soil is given by the ratio of liquid limit minus natural water content to the plasticity index. So option 3 is the correct answer. Question number 84. Quantity of water flowing through the filter arrangement as shown in figure. Means we need to find out the quantity of water, that is discharge. Write the given data by referring the figure. They given the coefficient of permeability of the soil, that is 1 into 10 raised to minus 7 meter per second. Write that permeability value and they also given the diameter, that is 2 meter. Now find area A equal to pi by 4 into d square. Put the value of diameter 2. 2 to the 4 get cancelled. Only pi remains. They given the head of water, that is h equal to 5 meter. And this height is the length of the sample. Now find length from here to here. 5 minus 3 is 2. So this height is up to here. And add 0.8 to get the length of the specimen. That is 2 plus 0.8, 2.8 meter is the length of the specimen. We know that hydraulic gradient I equal to h by L. Put the value of H 5 and L is 2.8. Then hydraulic gradient will become 1.7857. Quantity of water under the constant head permeability test is given by Q equal to K into I into A. Put the value of K, I and A. Then you will get quantity of water Q equal to 5.61 into 10 raised to minus 7 meter cube per second. So option 4 is the correct answer. Question number 85. A specimen of hard clay with diameter 0.06 meter and the soil sample fails under an axial load of 0.75 kN in an unconfined compression test. They given the diameter of the soil sample, that is 0.06 meter, and the axial load of 0.75 kN. The angle of failure is made at an angle of 30 degree with the axis of the specimen, that is phi equal to 30 degree. The lateral pressure in the cell required for the failure to occurs for a similar soil of specimen tested in a triaxial compression test at a deviator stress of 300 kN per meter square. Means we need to find out the cell pressure, that is sigma 3, with the deviator stress of 300 kN per meter square. Apply the sigma 1 formula, that is equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. For unconfined compression test, the cell pressure is 0, that is sigma 3 equal to 0, then the whole term will become 0. Only this equation is left. Now put the value of pi and simplify this, then you will get sigma 1 equal to 2c tan 60 degree. Sigma 1 is also equal to load by area. They given the load of 0.75 kN and area is pi by 4 into d square. Put the value of diameter, that is 0.06, then you will get volume of sigma 1 265.25 kN per meter square. Now moving to the second bit of the question, that is same sample is tested for the triaxial test. For triaxial test, sigma 1 equal to sigma 3 plus sigma d. Same here also use the sigma 1 formula and put the value of pi, that is 30 by 2 is 15, 15 plus 45, 60. Write the value of this term which was computed under the unconfined compression test, that is 265.25. Take sigma 3 into left hand side and sigma d into right hand side and put the value of sigma d. Take sigma 3 common from these two and this will become minus 2 and this answer will become minus 34.75. Minus get cancelled and take 2 into right hand side, that is 34.75 upon 2. Simplify this, then you will get cell pressure, that is sigma 3 equal to 17.37 kN per meter square. So therefore option 2 is the correct answer. Question number 86. Sand stratum at a site is 6 meter thick and water table is at a depth of 2 meter from the ground level. Draw the thickness of the sand layer of 6 meter and locate the groundwater table. If the soil gets saturated by the capillary rise to an height of 1 meter above the water table. Rise of water above the groundwater table by 1 meter due to the action of capillary rise. Then what will be the effective stress at a point 1.5 meter from the ground level? Initially above the groundwater table, the soil will completely dried and initial effective stress is given by unit weight of soil into height. That is gamma d into height 1.5 meter, that will become 1.5 gamma d. Due to the capillary rise, the final effective stress at a point P given by this 1 meter zone is completely dried, that is gamma d into 1. Below that the sand will saturated, that is gamma saturation into height 0.5 and pore water pressure, that is gamma w into 0.5. The saturated unit weight is greater than the dry unit weight. Similarly, final effective stress is greater than the initial effective stress. Now we conclude the effective stress increased due to the capillary rise. So option 2 is the correct answer. Question number 87. Soil which is not completely consolidated under the existing overburden pressure is called as the under-consolidated soil. So this is also simple and direct question. Therefore, option 3 is the correct answer. Question number 88. Following results are obtained from standard compaction test for a soil sample. They given the water content and dry unit weight of soil sample. Specific gravity of the soil solid is 2.7 and what will be the air content at 16% of water content. Write the given data. They given the specific gravity G equal to 2.7 and of water content 16%. For 16% of water content, the dry unit weight is 18 kN per meter cube. That is gamma D equal to 18 kN per meter cube. Now apply the dry unit weight formula with respect to air content, that is gamma D equal to 1 minus Na into G into gamma W upon 1 plus GW. Put the value of gamma W, that is 18, value of G 2.7 and gamma W 9.81. Same here also put the value of water content and G. Simplify this, then you will get air content equal to 0.0268. In percentage it is 2.68%. 2.68% is the value of air content. So option 1 is the correct answer. Question number 89 is based on the clay minerals. There are three clay minerals of engineering importance, namely kaolinite, montmorillonite and illite. Now kaolinite. This is the most common clay mineral of kaolin group, and the structural unit is made up of gibbsite and silica sheets, and it is also called as 1:1 clay mineral because of the arrangement of the one gibbsite site and the silica sheets. This type of minerals are formed when the ratio of silica to alumina ratio is very low. China clay is example for the pure kaolinite. The basic structural unit of kaolinite are bounded together by hydrogen, as the hydrogen bond are relatively strong. This rectangular unit is the octahedral unit and this trapezoidal is the tetrahedral unit. Now second clay mineral, montmorillonite. This type of minerals are present in expensive clay soil, and it is called as the 2:1 clay mineral because of one gibbsite sheet is sandwiched between the two silica sheets, and it exhibits the high swelling and shrinkage characteristics. This type of minerals are formed in an alkaline environment. Now coming to the last mineral, that is illite. Illite is similar to montmorillonite, but they have potassium ions between two structural units. As compared to montmorillonite, illites are the more stable. Thickness of the successive structural units of illite is 10 angstroms, and montmorillonite is also 10 angstrom, but thickness of kaolinite is 7 angstrom. Now coming to the question, a layer of gibbsite sheet joined to a layer of silica sheet is the basic structural unit of kaolinite minerals. So option 1 is the correct answer. Question number 90. An embankment with 1:1 side slope is constructed with a soil having the cohesion of 5 kN per meter square with the angle of internal friction is 22.5 degree and unit weight of 18 kN per meter cube. They given the side slope 1:1 and cohesion C equal to 5 kN per meter square, angle of internal friction 22.5 degree and unit weight of soil gamma equal to 18 kN per meter cube. The stability character for 1:1 slope with various angle of internal friction is as follows. They given the angle of internal friction phi and scalar stability number Sn value. What will be the height of embankment required for a factor of safety 1.5? Means we need to find out the height of the embankment with respect to factor of safety 1.5. Find the stability number with respect to angle of internal friction, that is phi equal to 22.5 degree. This comes in between 20 and 25. So that is write the value of the pi 20, 22.5 and 25. Now write the corresponding stability number for 20 and 25. That is 0.062 and 0.044. Now make interpolation to get the stability number for 22.5 degree. Write first term as it is, that is 0.062 minus this divided by this minus this into this minus this. Simplify this, then you will get scalar stability number Sn equal to 0.053. Now apply Taylor's formula for finding the height of the embankment, that is h equal to c upon fc into gamma into Sn. Put the value of cohesion, that is 5 and factor of safety 1.5, unit weight of soil is 18 and stability number 0.053 with respect to the angle of 22.5 degree. Simplify this, then you will get height of the embankment is 3.49 meter. The given 4 option 3.49 meter is the correct answer. So option 2 is the correct answer. Question number 91. A canal is 80 km long and has an average surface width of 15 meter. If the evaporation measured in a class A pan is 0.5 cm per day, what will be the volume of water evaporated in a month of 30 days in meter cube? They given the length of the canal 80 km. Convert this into meter, that is 80,000 meter or 80 into 10 raised to 3 meter, and width of the canal is 15 meter. They also given the pan evaporation, that is 0.5 cm per day. Convert this also into meter, that is 0.05 meter per day. Now we need to find out the canal evaporation, that is D equal to Cp into pan evaporation. Cp is the coefficient of pan evaporation, that is 0.7, and put the value of pan evaporation, that is 0.05. Then canal evaporation D equal to 0.035 meter per day. Now we need to find out the volume of evaporation V equal to D into A, where D is the canal evaporation. Put the value of that is 0.035, and area A equal to length into width. Put the value of length and width, then you will get volume equal to 4200 meter cube per day. They are asking volume of evaporation for 30 days. For that, multiply 30 to the volume. Then volume of water evaporated for 30 days is 1,26,000 meter cube. Option 4 is the correct answer. Question number 92. Direct runoff is the combination of surface runoff and the subsurface runoff. This is also direct question from the hydrology. So option 2 is the correct answer. Question number 93. Crop period. It is the time period elapsed from instant sowing to instant harvesting. This is from irrigation engineering. So option 3 is the correct answer. Question number 94. For economical construction of constant angle arch dam, the contact angle is in the range of economical contact angle for the arch dam is 133 degree 34 minutes. All options are similar to this. Option C is the appropriate answer for the 94th question. Question number 95. The relation between the dynamic viscosity and the kinematic viscosity. Kinematic viscosity is defined as the ratio between the dynamic viscosity and the density of fluid. It is denoted by V. Mathematically, it is defined as dynamic viscosity, that is mu, upon density of fluid, that is rho, and it is expressed in meter square per second. Option 3 is matching to this equation. So option 3 is the correct answer. Question number 96. Dash is the generally used mechanical device used for the pressure measurement, that is Bourdon tube pressure gauge. Piezometer is used to measure the pressure at one point. Differential U2 manometer is used to measure the difference of pressure in two pipes. Inverted U2 manometer is same as that of differential U2 manometer. So correct answer for this question is option 2. Question number 97. A pressure of 110 meter water is equal to dash meter of oil of specific gravity 0.85. They given the pressure height H equal to 110 meter and specific gravity G equal to 0.85. We know that pressure P equal to rho GH. First case take G equal to 1, then rho is also become 1. Now put the value of rho GH, then you will get pressure P equal to 1079.1 kilonewton per meter square. Now take G equal to 0.85, then rho value becomes 0.85 kilonewton per meter cube. Apply the same pressure formula, put the value of P, that is 1079.1, and put the value of rho, that is 0.85, and G 9.81. Keep pressure height for oil as it is and simplify this, then you will get pressure height for oil, that is H equal to 129.41 meter. So that is option 3 is the correct answer. Question number 98. Steady flow occurs when the velocity of successive fluid particles at any point is in the same successive period of time. So option 1 is the correct answer. Question number 99. In laminar flow, the pressure drop per unit length of pipe is given by 32 mu VL upon D square. So option 1 is the correct answer. Question number 100 and last question of this analysis series. For viscous flow, the coefficient of frictional is given by, that is the frictional coefficient F equal to 16 divided by R into N. And if they ask for frictional factor, the correct answer is 64 upon Rn. So correct answer for this last question is option 3.